Let's go through LeetCode 2925, maximal score after applying operations on a tree. For this question, to give us two-dimensional array edges, which represent a tree, and also n nodes from 0 to n minus 1, and each node has a value which is give us an integer array, represent the value of the node I. So we know the node n will be the value's length, right? For this question, you see that you give you can do the operations below. That initially you have a score which is 0, and in one operation you can pick any nodes I and add values I to your score and set these values to 0. And you see that a tree is healthy if the sum of the values on the path from the root to any leaf nodes is different than 0. So ask what's the maximal score we can get to remain the tree to be healthy. So let's you say that the node value is always a positive number. So so let's look at the example 2, right? So this edge represent the tree, and node 0 is 20, and 1 is 10, and 2 is 9, 7, 4, 3, 5. So the maximum score he can get is 40, and he picked this, this, and this. And the remaining root, every root, for example, from the remaining path from the root to any leaves, for example, this one, right? And this one. There are 4 paths. The sum will not be 0. Any path, the sum is not 0, right? So that means we can we need a leave of any of the paths that has the one node not picked. So how can we do this question? Intuitively, what's thinking about that is that we can from the node tree trying to going back backtrack going from the calculated the result from the leaves and going backwards to the root. So what we're thinking about is that it is pretty much like a post-order traversal problem. But for post-order traversal problem, what kind of result we should return, right? So we can think about for a node, right? If this node we do not take, right? We keep this node. We do not pick this score. That means all of the childs, right? All of the childs will tree will be safe, right? So if we take this, in order this tree to be health, we need all of its child tree to be health. If we do not take this, we don't care about the child, right? We can take all of the scores of its child. So let's repeat again. If we keep root, that is the root score will not add to our score. In order to get this kind of node healthy, and for example, we keep root. That means we don't need to care about its child. We can take all of its child, right? So this is one scenario. Another scenario is that if we take this node and add it to our score, that means our child need to be healthy, right? Our child need to be healthy. That means our child from the child to its leaf, right? Should every path should not be zero. It's not necessary we need to keep this, but we need to keep some but make sure that the child's are all healthy, right? Those kind of trees are the child tree is healthy, and those kind of sub trees are all valid. So what we're thinking about is that for this kind of DFS post trade conversal, we can return two values. One is if it is a healthy tree, what's the maximal result we can get? And the result two is the sum of the subtree. So we keep two values. So one result this is long, right? Result zero is if it is valid, what is the max score for this tree? And two is we can just get the sum of the subtree. So that we just get two results, and then in the end, right, we just do post traversal to backtrack to the root. What we retain is the result zero. So let's write code for this, right? We'll have this compose this age as graph, right? Let's use this equals new array list, and we can say arrays. This is array, okay, and should be a, right? Arrays set O graph A goes to new array list. This is equivalent to use a for loop for every to add a k n array list to this kind of arrays, right? So just to make sure you array set O, we cannot use arrays field, right? Arrays field. This will be wrong because it will give all of the array elements one the same array list. So this will be wrong. We should use array set all. Array set all is equivalent to use for loop to add array list. So what we do is that we compose the graph, and we're going to have graph age 0 add age 1, and graph age 1 and age 0. So we'll say we need to use a post order traversal result equals DFS graph, and we need to have the values, right? Because we need to count how many scores we get, and 0, that is our current, that is root, and because of we use those kind of map or to compose graph, right? So for every node, it adds all of its child and its parents. So we should also have the parents to be included. So we use -1 for the root, and return result 0. So we'll say private long. This is long DFS, right? And the list integer graph, and int values, int parent. Right? So for this kind of DFS, what we need to return is result 0 means max score of a health tree of health of health tree, right? With root at the current, and result 1 will be the sum of this tree. Every node, sum of all nodes, right? Nodes values of this tree. This can, we just, because we want to use this one to calculate to its parents. So this one is apparently not a valid tree. That's the second is just used for calculation, right? But this one is that the maximum score if this is a health tree and for this kind of node, right? So what we do is that if this is leaf, so how can we conclude this is leaf? Is that this size equals 1, right? And graph parent dot get 0 equals parent. So this means this is leaf, right? We make sure we also need the second condition because you see if we have 0 here and 1 here, right? It also just have a size 1. So for this leaf, right? So we need to make sure it's a the only element to get its parents. Then that means it is leaf. Then what we return? New int. So if it is leaf, right? In order this leaf to be valid, that means for this node, we cannot pick it. So the maximum score we get for a healthy tree for this kind of leaf is 0. And what is sum? Is just this node's value, right? So will be 0 and values are right. Okay. So then we have let's have results. Okay. What's new long two. So let's have two variables. One is sum of healthy all children all healthy children max scores. Right? That means if um so we'll see the result 0 is sum of current if it is healthy the maximal score, right? So that is we add the healthy child and the value. Let's have another one called sum all children values, right? Value it also equals to 0. So what we do is that for int next in graph current. So let's say if next equals parent, then we should continue because for this graph, it also has one connection to its parents. So we'll have long answers equals DFS graph values, and now we are iterate to next and current, right? The parent's current. So we'll sum all health children max score, right? Should add equal to answers there. And sum all children value should add equal to answers 1, right? So we'll say for result 0, it has two options. One is we pick current values. We take it, and then we need to make sure all of the children, all of the children, a child tree, right? They need to healthy. So we add those kind of healthy scores together, right? Another case is that we don't pick current value. Then that means we can just use all of its children's value as for this tree, right? So that will be the max. And the result 1 will be we just use the two values because that is just add every node's value, right? So it's simple, just this. And in the end, return result. Okay, doing like this, the post conversal, right? We just every node we traverse once. The time complexity will be O(n), right? And we use a graph, and this is linear also in space complexity. Convert this to Python code should be similar. We need, for example, n equals length values, and then we're going to have a graph equals, let's compose this graph first. For underscore in range length, and for age in ages, then we're going to have graph age 0 append age 1, right? And also we have graph age 1 append age 0. And we should have, for example, results equals DFS graph values 0 minus 1, right? Return result 0. So then we write DFS, right? The DFS. So we should have graph and the values parent. So let's say if this kind of length graph current equals 1 and graph current 0 equals parent, right? Then return first thing is that because this leaf we cannot pick leaf we cannot pick anyone, right? So that means the maximal is 0, and the leaves sum is the values current, and then we're going to have result equals 0. Let's have this, yeah, this one, right? And then what we need, sum, what we call the moment ago. Also we call just S1, S2, right? You should know S1 is the sum of all of the valid child score, maximal scores, right? Maximal valid child scores, and S2 is sum of all of the child values. It can not necessary to be healthy, but S1 need all of the children to be healthy, right? For next node in graph parent. So if next node equals parent, we should continue, right? And then with DFS answers equals DFS graph values next node parent, right? And let's say S1 equals should plus equal to answers 0. And S2 should plus equal to answers 1, right? Then what we do is that we know this result 0 should be max, right? That is if we take current one, that means we can only add the healthy nodes, some of the healthy nodes, right? So that will be S1. Otherwise, is that we don't take current one, then we can just use the S2, just follow the chosen child tree, right? Because if we don't take it, that means all of the child will at least these nodes from pass from this node, this will not be there, right? And the result one equals just sum them up values current plus S2 and return result.